The light enters the eye through the cornea. Cornea is a spherical surface, curved front surface. It is transparent. Inside this one, there is a space called iris and pupil. Iris is an opaque surface. It will not pass the light through it. But pupil is a transparent surface. It usually transmit all the lights to pass through. So it will reach the crystalline lens, and this crystalline lens adjusts its focal length according to the ciliary muscles. So ciliary muscles adjust and the crystalline lens focus, and the lights falls on the retina backside surface of the eye. So retina is on the backside surface. Here there are rod cells and cone cells, and these are able to see the object, which are cone cells can identify the intensity of the light, and the cone cells uh, can just understand the color of the light, and these cells sends an image to sends signals to the brain through the optical nerve. This is the process of eye, and through this process how the light is adjusting in the eye. And next, what we are assuming is, in order to adjust the lens, we have a mechanism with the ciliary muscles. For example, when ciliary muscles are relaxed, you can say that the lens can focus light on light at a distance 2.5 centimeter, that is to the distance to the retina. When the object is at infinity, the light clearly focus on the retina in this case. So we can say that ciliary muscles adjust in this way to get a clear image. So when the ciliary muscles which get tightened, or which is not relaxed, we know that its focal length changes, and according to the change in this focal length, the image will focus on the retina. This is the process of formation of image. Sometimes you can see that when the object is in front of the eye, it is very close to the eye, we cannot focus, or we cannot get a clear image of the object. In this case, we can say that there is a limit, or there is a least distance for distinct vision is there, that is called near point. It is represented as D, and for a normal eye it is 25 centimeter. For a 10 years child it may be 7 to 8 centimeters. And as aging progress, you know that an aged person of 60 years, it may be 200 centimeter, and this may be varies accordingly. So this is an ability of the eye. We can say that as for an aged person, this ability will not be worked, it will not be effective as in the middle age, means normal age. So what we are assuming is, this defect is called presbyopia. For a presbyopic eye, we cannot focus, the aged person may not be able to focus the image on the retina. The ability to focus different the objects placed at different distances inside the retina is called accommodation. It is an ability of the eye. The other normal defects are known as, first one is known as nearsightedness or myopia. Here myopic eye means when the light from a distant object arriving at eye lens may get converged in front of the, at a point in front of the retina. So we cannot see that eye. That is a problem. This problem it is due to the greater convergence, or much it is too much converged, this problem is handled, or we can correct it by placing a concave lens in front of the eye. And second one is called that is a different defect, in which the light coming from a point, near point, we cannot focus it on the retina. It will it will form, or the lens focus the incoming light at a point behind the retina, so we cannot see the object. This defect is known as farsightedness or hypermetropia. And the third one is called astigmatism. This is due to the this is occurs when the retina is not in spherical shape. The cornea could have a larger curvature in the vertical plane than in the horizontal plane, or vice versa. So due to this convergence, the person may not be able to look at a mesh or a grid of lines. He focus either the vertical lines or the horizontal lines. There is a distortion in this one. This distortion is corrected by a cylindrical lens of desired focal length. This is called astigmatism.